Yeah, for problem C, the operation is multiplication. So you can see that you're multiplying. So you're going to simply just multiply the coefficients and you will add the exponents. We get 12y to the 7th. Pretty straightforward. D, the operation is division, but we understand it's multiplication. Instead of adding, we'll just subtract to the powers. But first, I'm going to move the exponents to where they are not, those that are negative. So the b to the 7th will move up, b to the 3rd will move down, a to the 5th will move down. I get b to the 7th over a to the 5th, a to the 8th, and b to the 3rd. And now I can simplify that to b to the 4th over a to the 13th. So you've seen many different examples like these. This has been predominantly the heart of what you've seen in Algebra 1 and Algebra 2 during the second half of the year is practicing these things. So let's see how good your memory is. Try E and F on your own and see what you come up with. Let's try to identify the mistakes that we're more likely to make in these scenarios. 24x to the 13th, y to the 13th. Anybody know a mistake that people might make during this process? Yes. Right here. Okay, and so you got this. Oh, okay, so you took these two, multiply them together, and then you cubed it. Okay, good. Thank you for sharing. Yep. Yep, gotcha. Yeah, and so please would be the powers, so you would do that first. The parentheses really don't serve any purpose for this portion right here. You just take them off, they mean absolutely nothing, right? The only parentheses that matter are the second set of parentheses that group it for the power of 3. Now, the second thing that happens here that people will sometimes do, and I'd be surprised if nobody made this mistake, but often people will say that they need to distribute it. So they will, they'll cube it, and they'll get 3 times xy to the 4th times 8 x to the 12th, y to the 9th. And then they'll distribute the 3 here, and they'll distribute the 3 here to get 3xy to the 4th times 24 x to the 12th, y to the 9th. And that would give a total of 72. But you don't distribute the 3. You distribute the 3. It's distribution over addition and subtraction. Is there any addition or subtraction? So therefore, you don't distribute the 3. You would be really multiplying the 3 twice, which is not, does not maintain equality throughout the expression. So don't do that. So if you did make that mistake, you're not alone. All right, as we go to any questions on E? Move to F. What would you do first? Flip it all. 2x negative third, y to the 4th, over x to the 3rd, y to the 3rd. What mistake might people make when they're flipping stuff? They would maybe leave the 2 there because it doesn't have a negative. Or when they do flip it, they would change this negative to a positive. Those are all things that happen. Okay, they might forget to write the square down. That would be my mistake. Okay, I would forget to write the 2. Be like, okay, just took care of the exponent, I flipped it, but I forget to square it. So 4 x to the negative 6, y to the 8th over x to the 3rd. X to the 6, y to 6. Now we're going to move this guy down here, and we'll get 4y squared over x to the 12. Thumbs up if you got it. What a smart group of kids. All right, flip it. And then you see fractions. And when you see fractions, it's really quite unfortunate. Sometimes you see fractions, you begin to get this anxiety feeling. Like literally your stomach starts to hurt. The ulcer is starting to do damage to your digestive system. Just because of a fraction, you know what I mean? Like for example, I could write this and you're like, all right. But I could write this and all of a sudden you get angry. You know what I mean? It's incredible. The frustration that fractions have caused our lives. You ever met somebody that likes fractions more than integers? You just right. You just don't. Just in fact, we have studies in mathematics devoted to integer studies. Because we just like them. So whatever. We'll get over it. And here's the thing: when people see fractions, there's two things that come up right away. They number one, they common denominators. Every time you see two fractions, we make common denominators. So here's what people do: they say 2/3 times 3/4, and right away they're like, oh, I got to find common denominators. So they'll go, well, 4/4, so we get 8/12, and then let's see, times 9/12, and that would make 72/12, which is 6. There's hardly anything that's correct about that statement right there, but people do that. Okay. In fact, you only need common denominators when you add or subtract, right? Here's the other thing people love to do. This is I don't get this stuff. They love to say cross multiply. Well, why not? Let's just do it. Yeah, 8/9, I guess. Holy cow. Oh, you only cross multiply if you have an equal sign. Like what I thought that when I thought that this, I did cross multiplication. No, you multiply by the reciprocal. Whoever told you were cross multiplying is a liar. Okay? Yeah. All right. Some of you have unknowingly made up your own mathematics. You have a little branch going. None of it's right, but it's there. Or we're trying to get rid of it. Okay? All right? Someday you might develop your own branch of mathematics. We'll call it Justinian mathematics, and you'll take a course on study. Okay? So let us go and see if we can deal with the fractions. -2 times 5. -10. A to the, if they have the same base, what do I do to the exponents? I add them. So I've identified that I add them. Now, if I add two fractions, do I have to have common denominators? Yes. So that's 6/4, so I get 9/4. Done and done. But some of you will try to impress the teacher, which is a good thing. There's lots of ways to impress me. Cash gifts, food, those are generally good ways of doing it. But some of you will try to impress me mathematically, and you'll write this. Are those two expressions the same? They're the same. So why do I take a half a point off if you write that? Good thought. This is not simplified. What is a perfect fourth power? You can take out an a of 9. A to the 8th. So -10a squared, a root of a. So if you want to go this route, fine. But if you're going to impress me, then you better do that. How about don't worry about impressing me and just leave it as that? Yeah. Oh, yes. Okay. Thank you. Yep. So, see my point? We all okay? We do, and we celebrate mistakes. All right? We just know that you would like to make less of them than what you do, right? We're all in that boat. So, after a while, there's only so many 84s you can get on a test where you're like, oh, I'm ready to stop getting 84s. I want a 94. I mean, 84, you're like, well, I'm not even at the halfway mark of the B, you know what I mean? But it's still better than a C, so I should be happy about it. Okay? All right. H. People didn't do very well with this one last hour. You tell me, where do I even start? You would. Okay. So he's going to do that, right? So you want to rewrite it like this. Is that legal? Sure is. Way to go. So square root of 4 is 2, x to the third, y to the fourth, and then you got to cube that to get 8, x to the ninth, y to the 12th. Okay? Let's do it a different way. Most of you would do it a different way. Most of you would say power to a power, so I multiply. So 8 times 3 halves. 8 times 3 divided by 2, 12. So you got y at 12. 6 times 3, 18 divided by 2, 9. And then I have 4 to the 3 halves. So I actually have to take and the mistake that some of you will make is you'll actually take 4 times 3, which is 12, divided by 2 is 6. But the operation is power. So what do you do to your coefficient? You take it to the power. So you can either take 4 cubed, which is 64, square root is 8, or you can take 4 square root, 2 cubed is 8. So either way it works out. So Jen's is 100% correct. You can take the square root of it right away. And I like that option. I really do. I see this 2 here. That means square root. They're all perfect squares. Done. Fact is that most of your brains would probably more likely go to that route. But that's what's great about America. It's a free country. You make your own choices. Math invites lots of different choices. So, all right. What should I do? There's so many fractions. It makes your head hurt. What's the operation? It's power to power. So I multiply. So it'll be x to the 4/3, right? How about the bottom? Y squared, and then z to the 4/6, which simplifies to 2/3. Very good. So I only have my coefficient to worry about. What do I do with that coefficient? Do I drop it to the denominator? But it's negative. But it's not a negative power. So, yep, positive 16. Yeah, negative 2 times negative 2 times negative 2 times negative 2. So, yeah, so you're like, well, now I have a fraction in the denominators. Maybe I should multiply top and bottom by 3 halves, huh? No. It's okay to have a fraction and an exponent in the denominator. You can't leave an answer like this. Let's say you had x squared over 5 halves. That's a complex fraction. You can't leave that. But this is an exponent. You can leave a fractional exponent in the denominator. So, okay, 3 more problems. That's it. Not too bad. Okay, letter A. Perfect square, a to the 4th. All right. B to the 7th. Uh-oh. So what do I do? Reduce it by 1 to b to the 6th. And there we get a squared, b to the 3rd, root of b. Got a cubed root here. Kind of fun to write that cubed root, isn't it? I mean, you feel intelligent. It's like, oh, this is something that 8th graders would have no idea how to do, right? Right? Like, you write square root. I mean, all of a sudden, 5th graders might even know what that is. So. But cubed root, tricky. X to the 3rd, so I got to put an x over here, maintain equality. Y to the 6th. We get xy squared, cubed root of xy squared. Simplified. You try C on your own. Try C on your own. Yep, the operation for those two radicals says multiply. There are chiefly two different ways of doing this. Most people will choose one. Yep. So you just multiply them together and then take square root in the end. Somebody during the course of third hour decided that they would, and I applaud this. That's probably the quickest way is what we just did. But somebody first hour they did this. They did square root of b to the fourth times the square root of w times the square root of w to the fourth b to the eighth square root of w. And so they got b squared square root of w, w squared b to the fourth square root of w, and then they made a mistake here. Square root of w times square root of w is just w, so you get a w to the third, b to the sixth. They made a little mistake there, but that's valid. Whoop, that's a valid way to do it, but it does it probably takes you a little bit longer. You might be more likely to make a mistake. We all good? Okay, so I'm going to give you an assignment, but when I do, I just want you guys to understand something. That if you do ever come up here and check your answers out of the book, the way that they've divided up these solution manuals, this has the odds, and this has the evens. So I think that what people probably do for practice that works best is that they check the odds in their homework, in their book at night, and then they come in and they check the evens when they're here. So you do what you want, but I think that that's probably the most efficient way to get it. What? The odds are in the back of your book. Okay? And so I think that that's probably the best way to navigate and work through. So your assignment is underlined in red right here. You can. What's most helpful for me as I go through and grade your homework is yesterday's assignment or Friday's assignment that you have that on 1 page or 2 page or 3 pages, whatever it takes. But then as you begin a new assignment, you begin a new page. That's what's most helpful for me as I grade it. I'm not gonna take points off, but definitely makes it easier for me. Oh, it doesn't. Some of the books have pages that ripped out pretty, yeah. So, yeah, sure. We'll get you taken care of, kid. All right. Goodbye, you two.